this real quick. I'm gonna try and do the whole thing. So that sheet that I just gave you. All right, again, all these formulas are up here on the board, but again, make sure you look at what's where, because some of them are mixed around a little bit. The first one, Pythagorean theorem, I do have the equal sign first, so I do expect you to do this in the order of c squared equals a squared plus b squared. For the 45, 45, 90, and the 30, 60, 90 triangle, again, they're on the board over there. But I label one side as x, so the other two sides, the other leg should be the same. It should also be x. The hypotenuse should be the leg times square root of 2, so x square root of 2. On C, it was our 30, 60, 90 triangle. We have x on the short leg, everything based off the short leg. The hypotenuse is double the short leg, so 2x. The long leg is the short leg times the square root of 3. On D, we have the trig ratios. Now notice they're scrambled. I highly recommend you list out subtotal first somewhere on that paper. So again, some old hippie caught another hippie tripping on acid. So again, this means sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now, your paper might look exactly like mine. It might look different because I did have different versions on the test, so they might be scrambled from how I have it here. Just make sure you plug it into the correct corresponding places. So sine equals opposite over hypotenuse. So my sine is here in the middle. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. For E, we're talking about the geometric mean formulas. Again, that's these over here on the board based off of a right triangle with the altitude drawn in. The altitude is part 1 and part 2. So you're taking the geometric mean of part 1 times part 2 and then square rooting. Then you have the leg. You're doing the geometric mean of the adjacent part in the whole. So again, you're taking the adjacent part, multiplied by the whole hypotenuse and square rooting it. So that's what I would expect you guys to have when it comes time to fill in those formulas. All right, any questions there? Need to take a picture. I'm going to move on. Good. All right. Now, I rearranged this so that I'm doing them in order because in my first grade class, I just tried to do the top of the paper and then went back to the bottom, and that's kind of all over the place. So I rearranged them so that we're looking at the numbers in order. Number 1, this is using Pythagorean theorem. We have 2 sides of the right triangle. We need to find the third side. So you're going to use Pythagorean theorem. Now you have to decide which one of those is my C value. Well, again, your hypotenuse is always C. The other two can be plugged in for A and B in any order. So on this one, I'd be doing C squared equals A squared plus B squared. All right. In this case, I plugged in 5 for A and Z for B. Multiply them out. We have 7 squared is 49. 5 squared is 25. Z, and then we still have Z squared. Subtract 25, and we're left with 24 equals Z squared. Now we can simplify this. So it says simplified radical, no decimals. All right. So we can take this and simplify it. We have 24. We're going to break it down into 4 and 6. We can take the square root of 4, that'd be 2. So we get 2 radical 6 as our final answer. I forgot to show there. We took the square root of those to get rid of the square. That's why we did that. And our answer is 206. On number 2, looking for W. W is now in the position of our hypotenuse. So plugging that in, we have W squared equals 4 squared plus 8 squared. 4 squared, That's going to be 16. 8 squared is 64. Add them together and you get 80. You have the square root, both sides. Yeah, that cancels off the square over here. 80, it breaks down into 16 and 5. If you can find the biggest perfect square, square root of 16 is 4. So that's 4 radical 5. That's your answer. All right. And the next part is identifying if it's a right acute or obtuse triangle, or maybe not a triangle at all. So first thing I do is look through these and see if you can spot any that are Pythagorean triples. So there's a couple triples that you should be familiar with. Things like R 3, 4, 5, or R 5, 12, 13. Or again, there's other ones over there. Those are the two most important ones. Do you see those two anywhere up there? There's one that does fit a triple. It's one of these that's multiplied. Number 8 over here. This is our 3, 4, 5. Just multiplied by 3. So I don't have to do any other work to that one. That's going to be a right triangle. We can go ahead and label it as such. Now, the next thing you should do is look to see, all right, do you have any that won't form triangles? Well, 5 plus 8 is what? 13. That is greater than 12, so that makes a triangle. Go to the next one. 5 and 9, that's 14. That's greater than 11, it makes a triangle. 2 plus 4, that's 6. That's not greater than 8. So for number 6, that's not a triangle. On number 7, 8 plus 5, that's 13. That's not greater than 13. So this one also is not a triangle. Oh, all right. On 4 and 5, these two we need to plug in and see what they give us. Well, biggest number goes in for our c squared value. So 12 squared equals 5 squared plus 8 squared. 12 squared is 44. 5 squared is 25. 8 squared, 64. Add those two together, what do you get? Gives us 89. So the 144 is greater. That means this is obtuse. The c squared value is greater, it's obtuse. If the c squared value is less than, it's acute. All right, on the next one, 11 is the biggest number. So 11 squared equal to 9 squared plus 5 squared. That's 121, 81, and 25. We added those two together. That's 106. It's also c squared is greater. This is also obtuse. All right. Number 9 says, now this is starting the idea of our 30, 60, 90, and our 45, 45, 90 triangles. So for number 9, what if the side of an equilateral triangle is 21 centimeters? What is the height of the triangle? Now, most of the stuff that I've done so far, I definitely put those on the calculator part. Once we get to these, I told you there's going to be part of the test that's non-calculated this time. If it's doing a 36, 90 or 45, 45, 90, that's going to be on the non-calculated part. All right. So here we have ourselves a triangle. We split it in half. This was a equilateral triangle. All the sides were 21. And so the bottom piece is going to be 10.5. And since these angles are normally 60, this top angle is now 30. So we have a 30, 60, 90 triangle. We have the hypotenuse. We have the short leg. The long leg is the short leg times square root of 3. So that's 10.5 divided by 3. And we can leave our answer just like that. Oh, was that a question? Number 10, if the perimeter of a square is 24, so this time we have a square. It said the perimeter is 24. So what does that make each side? Well, 4 sides, 24 divided by 4 is 6. So each one of these sides is 6. They want to know what is the length of the diagonal. Well, when we draw that diagonal to the square, we make a 45, 45, 90 triangle. But these legs are 6. The hypotenuse is 6 radical 2. That's it. Questions on those? Yes. 9, yes. So on 9, when we drew in the altitude or the height of that equilateral triangle, it split that top angle. So what was normally a 60-degree angle, it's a 30-degree angle now. This is still 60. So there's 2 30, 60, 90 triangles. So that's this one, right? So our sides are acting like the hypotenuse in the right triangle. That bottom piece is our short leg, right? So we had the 21, we split it in half, got that piece, was 10.5, and then took the 10.5 and multiplied by radical 3, and that gave us the height, which was the long leg, the 30, 60, 90. Any other questions? Yeah. Skip 3. Oh, like I cut it off. What was the? Just to build a fence around the yard. I'm going to stick that in right here in this empty space. So I did somehow leave off 3. On 3, Jessica was building a fence. It said that the 2 legs were 9 and 11. We didn't know what the length of the third side was, but we needed to buy a fence to fence in the entire yard. So we had to find our hypotenuse on number 3. So we use Pythagorean theorem. Again, I'll plug x in for c. B squared equals a squared plus b squared. So x squared equals 9 squared plus 11 squared. 9 squared is 81. 11 squared is 121. That added together is 202. We take the square root of that. Now, when we take the square root of that, 202 is going to be 11 point something, because that falls between our 2 values of 196 and 225, which are our 2 perfect squares. This would be 14, that would be 15. So it's 14 point something. It doesn't actually matter what that decimal is. I know it's 14 point something. And the problem says I'm going to have to round up to the next foot because I'm buying the fence in feet. So I'm going to have to round up in this problem. So I'm just going to say it's approximately 15. So we have 9, 11, and 15. We need to add those together. 9, 11 is 20 plus 15 is 35. So 35 feet of fence is what we need to buy. That's number 3. Yes. All right. Any other questions here? All right. Thank you for catching that. I left 3 off. Trying to get up as fast as morning. All right. Next, again, still dealing with that 30, 60, 90 triangles. So we have the first one is a 45, 45, 90. If the leg is 12, the other leg is also 12. The hypotenuse would be 12 times square root of 3. Sorry, square root of 2. I mean 12 square root of 2. I wrote the right thing, but I said the wrong thing. So in our 45, 45, 90, our hypotenuse is the leg times square root of 2. All right, on 12 here, this one, we have a 30, 60, 90 now. We have the hypotenuse given to us. We have to find the short leg first. Again, everything's based off that short leg. If the hypotenuse is normally double the short leg, we have to divide that by 2. So C is 3. And then the long leg is the short leg times radical 3. So this would be 3 radical 3. All right, on 13, we have 30 degrees. Again, this is a 30, 60, 90 triangle. And this time they gave us the long leg, but it gave us the long leg as a whole number. Well, again, that can happen. That just means instead of multiplying by radical 3, I'm going backwards, I'm dividing off radical 3. So in order to go back here to E, I'm doing 9 divided by square root of 3. Again, when I divide by a radical, it's the same as dividing by what's underneath the radical and then multiplying by that same radical. So 9 divided by 3 is 3. So our answer here is 3 radical 3. Since we have a radical in that position, when we double it, we still have a radical for the hypotenuse as well. 3 times 2 is 6, so we get 6 radical 3. On 14, they give us the hypotenuse again. They gave us a whole number where we normally have a radical that normally has a radical 2 on it. So we have to divide off the square root of 2. And when we do that, just like on the last problem, it's the same as dividing by what's underneath the radical and multiplying by the same radical. So 16 divided by 2 is 8 radical 2. All right, on 15, this is starting our sine, cosine, and tangent. So you might want to write out your ratios so that you have some old hippie off another hippie dripping on acid. Sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Now, on number 15, we are looking at angle A in each of these. So angle A is here. Since angle A is there, we are going to use A for every single one of these. And we need to label all the different parts. 13 is my hypotenuse. 5 is my adjacent. And 12 is my opposite. So I have hypotenuse, adjacent, and opposite. Now, sine is opposite over hypotenuse. So opposite was 12, hypotenuse was 13. Cosine. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse is 5 over 12. Tangent is opposite over adjacent. Whoa, sorry, not over 12, over, my bad, over 13 on cosine. Cosine, I said the right thing, but then I wrote the wrong thing. Adjacent over hypotenuse, which is 5 over 13. Tangent, now opposite over adjacent. So opposite was 12, adjacent is 5, 12 over 5. All right, and 16. Set the ratio to solve for P, but do not evaluate. So they want us to solve for P. They want us to get P by itself, but we're not actually going to find a whole number. And this is something that I could also put on the non-calculated part. So I'm not having you plug in, I'm just having you write out the equation in order to solve. This is also something that I've definitely seen on the EOC several times in the past. And when they do this type of problem, they usually have the equation editor where you actually have to type in like the little equation. So on here, we have 62 as our angle. What 2 parts do we have? We have the hypotenuse. We have the adjacent. Hypotenuse and adjacent. That's cosine. So we have cosine of 62 degrees equals 6 over P. Now, P is not by itself. We need to get P by itself. We're not actually going to plug it into the calculator, but we still need it by itself. Well, P is on the bottom. So multiply P to the other side. Cancel off here. We now have P times cosine of 62 equals 6. When you get P by itself, this is currently multiplication between here. We're going to divide off cosine of 62. So P equals 6 over cosine of 62. We're not actually putting that into the calculator yet. That's all we want us to do, because they said do not evaluate. So they don't want to find an answer. They just want to represent it as a ratio. All right, on number 13, now we're starting to actually plug things into our calculator. Before we do this section, since we're going to have to use sine, cosine, tangent, what do you want to double check in your calculator? It's in degrees. Again, you want to look for DEG on the top of your calculator, make sure it's in degree mode. If it's not in degree mode, then you're going to have problems in this section. All right, just so I can show my calculator as we do this section, I'm going to do this part from over here so I can write and show my calculator. Give me 1 second.
that there. Make it a little bit bigger. All right, so for this next one, we have round to the nearest hundredth, right? So we're going to be using sine, cosine, and tangent. Which one are we going to use here? Well, again, label our figure. So we have the 32 is what we're using. We have the x is going to be what side? X will be the opposite. 12 will be our adjacent. So opposite and adjacent, that is tangent. So we have tangent of the angle measure 32 degrees equals opposite over adjacent, which was 12. We need to get x by itself, so we need to multiply by 12. So times 12 times 12 and cancels off from that side. That's what we're plugging into the calculator. So we get on the calculator 12 times tangent of 32. So I'm going to hit 32 tangent, and then I have to hit my equal key, and that gives me 7.4984. What are we rounding off to? Hundredths place. So that's 2 decimal places. Well, that 8 is going to make this 9 round up. So this actually rounds up to 7.50. So technically we did end up having to round it to a tenth because that hundredths place was a 9, it rounded up. So we got 7.50. All right, questions there before we move on? Wait for just a second so I can take a picture of it all. Clear. All right, next part. Oh, of course, this is in the way now. Put that over there. All right, now we got for 18 to 20. Same thing. All right, you're gonna have to use a calculator. We're using SOHCAHTOA, so I'm gonna write it out again. Some old hippie caught another hippie tripping on acid. All right, so I got my statement there. We have, this is our angle. We're finding an angle this time. We have 2 sides given to us. We have the hypotenuse. We have the opposite. Opposite and hypotenuse is sine. So sine of F equals opposite 26 over 32. In order to get F by itself, this is again, finding an angle, we have to get rid of sine. We are doing an inverse function. So sine to the -1, that's an inverse of sine of 26 over 32. Plug that into the calculator. Again, you can do it a couple different ways. I'm just going to type it as a fraction. So 26 over 32 equals, oh, I didn't have to equals, sorry, inverse sine. Let me try that again. 26 over 32, second sine. There it is. We got 54.34. To round to nearest degree. So we're going to just round this off to 54 degrees. That's our final answer for that one. All right, round to the nearest hundredth on the next one. They give us the angle this time. We're trying to find W. Well, these 2 pieces, we have the hypotenuse and we have the adjacent. Hypotenuse and adjacent, that is cosine. So cosine of 64 equals adjacent over hypotenuse. So multiply the 7 off the bottom. Now cross off from that side. And this will actually give us our answer already. So plug it in. 7 times cosine of 64. So 64 cosine equals 3.06859. Again, hundredths place. So we're rounding this up. 3.07 will be our final answer. All right, go on to 20. On 20, this is the angle that they gave us. Yes. On this one, yes, again, adjacent's next to. So we always have to look at wherever the angle is. So like on this last one, that side was opposite, but that's because we have the angle down here. On this one, we had the angle in the top corner. So the one that's next to that is the adjacent piece. So wherever the angle is, that determines how to label it. All right. Good question. All right. On 20. So we're using this angle this time. Well, based on 48, 6 is going to be the opposite side this time. K will be our hypotenuse because that's across from the right angle. Opposite and hypotenuse, that's sine. So we have sine of 48 degrees equals 6 over K. Oh, now we have our variable on the bottom. Still got to multiply the denominator out no matter what. So we get K times sine of 48 degrees equals 6. To get K by itself, we are multiplying currently by sine of 48. So divide off sine of 48. So plug that into our calculator. What does it give us? Clear this out. 6 divided by 48 sine equals 8.07379. It said round to the nearest tenth. So we're going to round to 1 decimal place. So 8.1 is going to be our answer. Questions there? All right. Save this. Clear. And we got one more set of problems here. I think I'm hiding something here. I am. And I don't really need this anymore. All right. Whoa. All right. On here. Geometric mean. I'm going to go through these real quick. Again, anytime we do geometric mean, it's the square root of the product of two numbers, 16 and 18. On this one, it's actually better if we don't multiply because 16 is already a perfect square. 18 is 9 times 2. So I could do the square root of 16 and the square root of 9. That would give me 4 times 3. The 2 stays under. That's 12 radical 2. On the next one, this one, we have to put them in the correct order. This was like the very first thing we did in this section. I used dots when we did this. 1 for the smallest angle, 2 for the medium angle, 3 for the right angles. So looking at this, RST, RST. That's 2, 3, 1 in order. 2, 3, 1. So follow that same order for the other ones. The small one, 2, 3, 1. That's RPS. Triangle RPS. For the big one, or the medium sized one, 2, 3, 1. SPT. SPT. For number 23, these are the two geometric mean formulas that we had on the board there. So this one gives us, this is 2, this is 6. The whole is going to be 8. We're finding the leg. Oh. All right, I'll post these last couple. All right, I'm going to finish talking real fast, but I'll post these last couple. So this is a leg. So we're using our leg formula, which is the adjacent leg. The adjacent part, I mean, times the whole. Adjacent part on this one is the 6. You too. And the whole here was 8. So we have 6 times 8. 6 times 8 is 48. We can take 16 out of that. That's 16 and 3. Whoops, I said 2. 16 and 3. So that's 4 radical 3 for our final answer on that one. On 24, like I said, I will post these. All right, so don't feel like you have to get them right now. On 24, you have PT is 5, ST is 8. PT is 5, ST is 8. What is RT? So they wanted the entire length here. Again, that's a leg formula. So 8 is equal to the square root of 5, which was the adjacent part, times the whole, which was x. Square both sides. I'm just finishing our thing from last period so I can post this. That's 64 equals x. Wait. I did something wrong. No, that's just a really big triangle. We had 5 times the whole. This side was 8. We got rid of it. We squared it. Squared that side. Uh-oh, no. Okay, there's the 5. I left off 5. Last spot, divide by 5. So 64 divided by 5, that's going to give us 12.8. That would be my answer. All right, 12.8. That's x. And then finally, the last one, they give us PR is 8, PT is 18. What is PS? So they want us to find the altitude. Well, first thing, oh, actually, we don't even need the whole on this part because for altitude, it's just part 1 and part 2. So we have 8 times 18. Can you let them in? Thank you. So we have 8 times 18. That's 144. Square root of 144 is 12. And that's our final answer. And that's the whole review. Hold on 1 second. Give me 1 second.